Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that a plate cam rotating clockwise is to give an inline point follower the following motion: 0 to 120 degrees lift, 32 mm with uniform velocity, 120 degrees to 180 degrees swell, 180 degrees to 360 degrees fall, 32 mm with simple harmonic motion. Draw the cam profile if the minimum cam radius is 38 mm and the camshaft diameter is 24 mm. So, first we will draw the center line. So next we are going to draw the camshaft. From the question, the camshaft diameter is 24 mm, which that means the radius is what is 12. So we will thicken this camshaft. Then the question states that the minimum cam radius is 38 mm. So we'll measure 38 mm. 38 mm. Then the lift is 32 mm. So we'll just come here and mark 32 here. Then through this point, we'll draw the 32. Now from the question, the cam rotates clockwise in clockwise direction. So we'll do like this to show the clockwise direction. Now, when the cam rotates in a clockwise direction, that means the follower rotates in the opposite direction, which is anti-clockwise. Now, we will draw from this point, we will draw the knife edge follower. The question states that to give an inline point follower. So we'll draw the inline point follower. It's at this point. So we'll draw the follower. So since the cam is moving in clockwise direction and the follower is moving in anti-clockwise direction, we have to divide this cycle into 12 sections. You can divide it into any number of sections you want, but I'll divide this one into 12 sections, each one being 30 degrees. You can also divide to 15 degrees, depending on how you want it. So let's divide it. So we have successfully divided it, and then we'll join the lines. Then we'll join these points. So that's it. So this one, the follower will rotate like this, while this one, the cam is moving like this. We'll put the degrees of the follower now. So this one is what? This one is 0 degree. This one is what? 30. This one is 60 degrees. Here is 90 degrees. Here is what? 120 degrees. Here is 150 degrees. Here is 180 degrees. Here is 210 degrees. Here is 240 degrees. Here is 270 degrees. Here is what? 300 degrees. Here is 330 degrees, and here is 360 degrees. So then the next step now is to draw a cam graph. So we will project this point from here, project it, and from the top here we also project it. So then here also. So this is 0 degrees. Now our cam graph will have a scale. The scale I'm going to use is 10 millimeter to 30 degrees. I'm going to use a scale of 10 millimeter to 30 degrees. So and there are 12 divisions here, so we'll get 12 divisions here also. So it will be the first division: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then so in the same way, this one will be 30, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and 360 degrees. So now, question states that there is 0 degrees to 120 degrees rift, 32 millimeter with uniform velocity. That means from this 0 to 120 degrees, there's a rift, of 32 millimeter with uniform velocity. We use a straight line curve to represent rift for uniform velocity. So uniform velocity is represented by a straight line curve. So from here, from this 120 to 0, you draw a straight line curve to represent the uniform velocity. So this represents the uniform velocity. Then there's 120 degrees to 180 degrees dwell. So from this 120 to 180, there's a dwell. It's represented by a horizontal line, dwell. So you draw a horizontal line. Then finally, there's 180 degrees to 360 degrees fall, 32 millimeter with simple harmonic motion. Now, when there's simple harmonic motion, you have to use the cycle. So we have to get the half of this 32. The half of 32 is what? Half of 32 is what? Is 16. 16. So you have to mark 16 here. And draw the line. Then then draw the cycle here, the semicircle. Now, then you divide the cycle. You count the number of divisions here. 1, 2, 3. You know the simple harmonic motion is from 180 degrees to 360. So you have to count the number of divisions there. 1, 2, 3, 4, 5, 6. That means you divide this semicircle into 6 divisions, 6 equal divisions. So if there are 4 divisions here, you have to divide the semicircle into 4 equal divisions. So the length of this is the radius. So use the radius to divide it. Just like I did at the beginning. Then you join it. at this point is here, so you mark it. Then at this line, the second is the line that touches here. But first of all, let's join this to the center, though it's not necessary, but let's join to show the divisions. Then, so this one, these are now 1, 2, 3, 4, 5, 6 divisions. That's how there are 6 divisions here. So we'll now, this one, the first line, this point is this point, and the second line, second division, you join it here, so you mark this point. The third one, third line, you mark this point. This one to be to here, you mark this point. This one, you mark this point. Then this one, you mark this point. Then finally, you mark this point. So you see, this is a simple harmonic motion curve. When you use your French curve, you can use this one now. So you have to take in this graph. Then so that is it. And finally, we are going to transfer the dimensions here to the diagram, this diagram. So this line, this base cycle, will represent here. So we'll find the distance like 0 now. For example, 0 is on the line, it's on the base cycle. So our point will be here at this point. Then the next one, 30 degrees. You measure, you put your compass, 30. Then you come here, 30 from the base cycle, you mark. You go 60. You come here at 60, you mark. 90, you come here at 90, you mark. At 120, you come here at 120. 120 is the same as this point. So at this 120, is the same here from the diagram, the same 120, 150, 120, 150, and 180. They all have the same length from here to here from the diagram. So then continue from 210 210, yeah, then 240, 240, then 270, then 300, then 330. 330 is even smaller than the smallest dimension of the compass, so we can use this 2, that's 2 millimeter, then 360 is back to the same point. So we have gotten our cam profile. We now need a French curve to join it. So now we'll join it. To thicken it, you can bring it out small. Then you fill the area like this. And here we'll just use our compass. So this is the cam profile, and this is the cam graph. Let me write it. So here is the cam profile. That's the movement of this follower anti-clockwise as this one moves, as the cam moves clockwise. And here is the uniform velocity rise. UV stands for uniform velocity. Here is the dwell. Here is the simple harmonic motion fall. SHM stands for simple harmonic motion. Yeah. So, and here is the cam graph or the displacement graph. And here is the cam data. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.